just pop stars and successful Hollywood actors, and even the author of Watership Down, who we've lost this week, in a annus horribilis when it's come to important deaths. We've also lost one of our pioneering scientists this week, I regret to say. Astronomer Vera Rubin, who helped discover dark matter, passed away a couple of days ago at the age of 88. And to tell us more about her legacy and her career, we're joined by Vanessa Moss, an astronomer at the University of Sydney. Good morning, Vanessa.
Good morning, Chris.
So how important was Vera Rubin's work? Was she a pioneer, would you say?
She was a pioneer in a lot of different ways. So not just her science. So her science was pioneering. She did lots of groundbreaking. Sorry, I should say close.
It's all right.
She did lots of groundbreaking work in various fields in galaxy studies. So studying the motions of galaxies near our Milky Way home galaxy. She studied the rotation of other galaxies, which leads into her work on dark matter. But she also studied clustering of galaxies. So in every way, all the different things she did scientifically during her life were pioneering. But she was also a pioneer female astronomer at a time where there really weren't many.
Well, let's talk about that. I mean, what sort of period are we talking where she was doing the bulk of her work, and how unusual would it have been to have a female looking through those telescopes and reporting, in the labs?
Very unusual. So she was born in 1928. By the time she was doing her master's studies, it was the late 40s, and she was one of the only women that were even allowed to do astronomy at all. So one of the interesting stories about her is that she applied for Princeton to do, I think it was postdoctoral studies, but they said no, because at the time they weren't allowing women into their graduate astronomy program.
And so they were actually forbidden?
Yes. So it wasn't until 1975 that changed. And so she was living in, the 50s, the 60s, at a time where women weren't allowed to go to observatories. They weren't allowed to be astronomers in general. Science, it was often that if there was a female astronomer or scientist, they might be the only female in their class.
Right. So how did she successfully break the glass ceiling, as it were? What did she do to, bash down the doors and be allowed in?
Literally bashing. So she was, I guess, the kind of person that if someone says you can't do this, she would say, well, I'm going to do it anyway. So she saw the barriers as obstacles to be overcome, which I think is really admirable and inspiring, because I'm not sure if I was in the same situation, would I act the same way? And so when she was told at the end of high school, oh, you'll be fine as long as you avoid science, she's like, well, I'm going to do science anyway. And there's actually an interesting story. She was applying for a place called Swarthmore College. I don't know much about it, but apparently she was doing the interview to be a science major at this college, and she just offhandedly mentioned that she liked painting as a hobby.
Right.
And the admissions officer said to her, oh, well, have you ever considered painting astronomical objects as a career path? And so she said that became a tagline in her family for whenever something went wrong. She'd be like, well, have you ever considered a career painting astronomical objects instead of studying them, which is what she wanted to do?
Yeah. And do we know much about her family? Like, where did her love of science come from?
So I think it's interesting. If you look at her family, so her father was an electrical engineer, so obviously part of it came from there. Her mother actually was working for a telecommunications company and helping them measure mileage. So obviously she was also in kind of a quantitative, maybe even sciencey role at an early time. She had an older sister who went into law. And I think, I wonder this, if you look back, she didn't have any brothers. So this was a time where, in the era where you look at it and okay, girls were said to be in this role, guys were said to be in this role. If she'd had a brother, would things have turned out the same way? Because she had a sister only. And so I don't know how that played out, but obviously she grew up with a love of science. She was said to, she had a bed next to a window, and she would look out the window at the stars, and then she'd wake up in the night and the stars had rotated, and she just thought that was incredibly cool. How does this even work? And so that, even from a really early age, had that love of knowing how the universe worked.
Yeah, wow. Just out of interest, as a bit of an aside, what are the gender numbers like today in universities in astronomy?
Yeah, so I was looking this up, actually. So we have a global astronomy association called the International Astronomical Union, and this is professional astronomers worldwide, so people who have PhDs and above who are part of this group. It's about 10,000 people. So back at the time when Vera Rubin was pioneering, there would maybe be a handful of female astronomers worldwide. These days, the average is about 13%, which is still quite awful.
Slow.
In Australia, it's about 15% of the 260 or so people who are members of that. So we're a little bit better. The best, I think, is Argentina, which is at 26% or so.
Right.
But still, there's a lot of work to do.
There's no reason I can think of why it should be a male-dominated industry, but I guess science has always sort of had that issue to deal with, hasn't it?
Yeah, so historically, I guess it was, they were forbidden at one point.
Mm-hmm.
There's no forbidding of women to enter astronomy or science now, which is great. Like, I wouldn't be here if that was still true. But I think it's a slow changing process. So Vera herself was quoted in like the early 2000s as saying, I thought anything was possible decades ago, but now change is happening, but it's happening so slowly. If you look at it, I mean, 15% is good. Like it's a really big improvement on 0%. But it does take time because you have a lot of different factors at play, like commitments, family commitments. How do you balance the work-life balance? I mean, this is true for guys and girls, but in society, it's not always easy for girls to manage that as easily.
Let's look at Vera Rubin's legacy as an astronomer. Now, she made some breakthrough discoveries, in particularly in the area of dark matter. Now, before we get into Vera's work there, let's just take a step back for dummies like me. What is dark matter?
So it's a better name than black hole because black holes aren't black or holes really. But dark matter is a name given to what we see. So when we look at a galaxy, we can see that there's more mass. So what we see from the light from stars or from gas is one thing, but when we look at how the galaxy is moving, how it's interacting with its surrounding environment, that tells us there's more mass there. So there's more stuff there than we can actually see with our telescopes.
Mm-hmm.
And so that name was given dark matter because it interacts gravitationally, so it can pull things, it can move things, but we can't as yet detect it with our telescopes.
And what was her big contribution to dark matter research?
So her big contributions, this came about in the 60s. So she worked with a guy named Kent Ford, and they had a really, really good spectrometer. So this meant that they could study the emission lines from stars or star-forming regions. She started off studying something called quasars, and interestingly, she thought it was too competitive because it was a really hot topic at the time. So she's like, I want to do something where I can make a breakthrough or do headway, but not have all these people trying to fight me for the result. So she moved into studies of how galaxies were spinning, and she studied our nearest big galaxy neighbor, the Andromeda galaxy.
Mm-hmm.
And so what they were studying, if you look at this galaxy, there's star-forming regions across it. And with this really good spectrometer, they could measure how fast these star formation regions were moving.
Mm-hmm.
So if they're moving towards you or away from you, it shifts like a Doppler thing, red or blue towards in that part of the spectrum. And so they studied this, and what they expected in our solar system, if you look at the sun and you go outwards, things slow down as you get to the outskirts. They expected the same thing because the mass distribution, all of it's concentrated in the center. What they found was that no matter what distance from the center of a galaxy you looked at, it was rotating at the same speed. And that didn't make sense from a gravitational point of view.
Right. And so there was sort of talk, was there not, that Vera Rubin's work really warranted her a Nobel Prize. Now, I don't know whether it was sexism again that got in the way of that, or whether there was just, so many other deserving scientists and astronomers in particular. Do you have a view on that?
Yeah, so I think firstly, it is complicated, like you kind of implied, that Nobel Prizes, no one really knows how they make the decisions. So Sweden is like this mysterious place. But the history of dark matter itself is complicated because people were kind of speculating about something as early as the 1930s. So they were doing observations, people like Zwicky, Oort, Kapteyn. So these astronomers were doing observations and seeing something there that didn't quite fit. What Vera Rubin did was the first big convincing set of empirical evidence for something called dark matter. But after her, if you look at her paper on this, the first paper she wrote, she actually references studies in radio astronomy. So radio astronomers had studied the hydrogen gas instead of the stars, and they'd found a similar thing, that the rotation curve, or the way the galaxy was rotating, was the same out to large distances. Hers was a bigger deal because it was a larger set, it was more convincing. And I think the credit that she deserves is that, you can have a discovery, but if you don't stick by it and you don't defend it and make sure people know about it and fight for it, it might just fade away into non-existence like some of these other discoveries did. Right. So I think my personal opinion is that she definitely should have got a Nobel Prize. She should have been part of a group of people awarded it, and they've really missed an opportunity there.
So just finally, Vanessa, obviously a big week of deaths. We've seen George Michael go, Carrie Fisher today.
2016 has not been good.
Vera Rubin, no, not a good year. Is Vera Rubin the big one for you? I hate to make you compete in your grief, but for the astronomy community, this is big news.
Yeah, it is. It is huge. There is. I mean, if you look at the astronomy community, a lot of people thought she did deserve the Nobel Prize, and they cannot award it after someone has died. So they've missed the chance there. Personally, I mean, I think Vera Rubin, along with in Australia, Ruby Payne Scott, and other women trailblazers around the world, I mean, they really didn't take no for an answer. They kind of did it anyway because they were interested. They did what they loved. And that's really set the path for people like me, for people like my supervisors to follow, because it's a lot easier for us now than it was then. And yeah.
Well, thank you for giving some perspective on that and telling us, well, for many people, be introduced to the world of Vera Rubin. And thank you very much for letting her know how she's influenced you.
Thanks.
That's Vanessa.